Using the link on Google Classroom, adjust the sliders to see the impact that A, B, and C have on your function, and record your thoughts on your paper. Then you can resume this video and we'll compare our results and see what you noticed. By changing the A value, we could see that it's a vertical stretch. When A is greater than 1, it's increasing A times faster than it was before. When A is between 0 and 1, it's A times slower than it was before. And we also saw when A was a negative value, it got reflected over the x-axis. When we adjusted the B value, we saw that was a horizontal change. In fact, it was a shift to the left or to the right. In our expressions, if we see an x plus b, that's going to the left. If we see an x minus b, it's going to the right. It's the inverse operation of what you think is happening for the movement on your graph. When we adjust c, we know that that's a vertical shift. And so when we had a plus c that moved it up so many units, and down c was the minus so many units. As we saw in our previous lesson, we know what their parent function, y equals 1 over x, looks like. We have our parent function table, again, where we looked from the inputs from -3 to 3, counting by ones, and their corresponding outputs. Remember, when you have an input of 0, 1 over 0, that's undefined. So that's creating an asymptote. We also saw that as we changed the input values for x, they were getting closer and closer to 0, but not equaling 0, which gave us our horizontal asymptote of y equals 0. That impacts our domain and our range. So for our domain, again, looking at the inputs, the x values that we can use everything but the 0 because of our asymptote. Therefore, our domain would be from -infinity to 0 in union from 0 to positive infinity. Again, eliminating 0 as an input. For our horizontal asymptote affecting the range, same idea. We're looking at the outputs. So we're using outputs all the way up to 0, and then everything above 0. So here we're showing how the range from -infinity to 0 and 0 to positive infinity is eliminating an input of 0 being, an output of 0 being used. So now we're going to create some graphs based on the transformations we see in the equations, and then discuss the key features like domain and range, asymptotes, x and y intercepts. The parent function here we said cannot have any x-intercepts because we know we can't have an output of 0. It will not have a y-intercept because we know we have an input of 0 giving us something undefined. So here's our first function. Y equals 1 over x plus 1 plus 6. The first step is identifying how many transformations are happening and whether they affect the inputs or outputs. Comparing it to my parent function 1 over x, I can see two transformations. One coming from this x plus 1 and one coming from the plus 6. Here the x plus 1, since x is the input, this is an input change. Remember, input changes are the inverse as they appear. So this is moving to the left 1 unit. So we're going to have to take all those original inputs and move them to the left 1. Here the plus 6, that's affecting the outputs, the y's, and so we're going to have to change those outputs by adding 6 to make it go up. So again, here's our parent function table, and we're setting up the transformations based on what we saw. Again, a horizontal shift to the left algebraically means we're subtracting 1 from each of the inputs. Vertical shift up 6 means we're adding 6 to the outputs. So by completing those transformations in our table, these are now the corresponding inputs we should have and outputs we should have based on those two transformations. This is what's generating the points we're going to graph for our transformed function. So here's 1, -4, 5 2/3, -3, 5 1/2, 2, 5, -1 undefined, 0, 7, 1, 6 1/2, 2, 6 1/3. So we can plot the points for the graph and see what happens. So plotting our points, we saw the curves developed, and we know that also we should have some asymptotes. Now think about the transformations that we did. We moved everything to the left 1 and up 6. So the asymptotes would follow suit. Our asymptote vertically normally was at 0. If we move it to the left 1, here we have our vertical asymptote. And then our horizontal asymptote here at y equals 0, if we moved everything up 6 units, would also shift up 6 units as well. So now that we have the graph completed, we can look at the key features. And so we usually start by talking about having any x-intercepts or y-intercepts. And we can tell in our table that we have a y-intercept because we have an input of 0, and we have our output of 7. So right here is our y-intercept, 0, 7. Because of the shifts that we did going to the left, we also have an x-intercept here, and we could approximate its location. We also could find its exact location because we know the output is 0. So we could put 0 into y, and we have our function also as a y, and see where the two intersect, and see exactly where it's at, and record the data. So it looks like it's just before -2, and if we look at the intersection, we'll find out that it's at -1 2/3. So we have our x-intercept, -1 2/3. We have a y-intercept, 0, 7. We already talked about the asymptotes, how x was at -1 and y was at 6 because we moved it up 6 units from where it was originally at 0. If we want to talk about the domain and range now, those have been impacted because of the shifts that we did. For our domain, typically it was all of the inputs except happening at 0, but because we shifted it to the left 1 unit, our asymptote is here at -1. So we're going to have to say our domain goes from -infinity to 1, but not including it, and then greater than 1 to +infinity. If we look at the y's, the outputs, again, normally an output of 0 was causing a problem for our range, but since we moved our function up 6 units, we now are going to have our y asymptote here. So y equals 6, that's going to be our range impact. So we have -infinity to 6, and then from 6 to +infinity using the correct notation. So we're putting those into union with each other. So again, here's our correct domain notation and our correct range notation. Let's try another function. Again, we want to compare this to our original parent function. So we've got y equals 1 over the quantity x minus 2 plus 4. Again, the first step is to look to see how many transformations are occurring and do they impact the inputs or outputs. So again, we're comparing this to our parent function, which is 1 over x. As you can see that there are two transformations happening. Right here is x minus 2. Again, it's an input change, so we're going to have that moving horizontally. And if we see the -2, we have to remember we're moving that to the right 2 units. So it's the inverse of as it appears. We're going to have to add 2 to all of the inputs. And here's our second transformation, the +4. That's going to be an output change, a vertical change, moving it up 4 units. We're going to take all of the original outputs and add 4 to them. So if I conduct the transformations for the inputs and the outputs, these are now the new points that are going to make up our function. And so we can plot them accordingly and create our graph. Now again, thinking of the shifts that happened, moving to the right 2 and up 4, that also impacts your asymptote. So again, normally we had a vertical asymptote at x equals 0. By moving it to the right 2 units, we're going to have a vertical asymptote at x equals 2. Our horizontal asymptote was at y equals 0. By shifting it up 4 units, now our horizontal asymptote is going to be at y equals 4. Because of these shifts, we're now going to have x-intercepts and y-intercepts. We're going to have to watch those in the table and in the graph. Graphically, we can see that we have a y-intercept, and it also shows up in the table because the y-intercept always has an input of 0. So for us, our y-intercept is at 0, 3.5. The x-intercept, we can see it's in between 1 and 2, and we could find that by doing a systems of equations, by putting a 0 in for y, and then we have our function also in for y, and finding where they intersect, and we can pinpoint exactly where that's at. Again, notice how the asymptotes are going to impact your domain and your range. So our domain, we can use all those numbers except an input of 2. And the range, we could use all those numbers except an output of 4. So let's check our notation on our function. to recap, we said we have an x-intercept at 1.750 and our y-intercept at 0, 3.5. Looking at the asymptotes, we have the correct notation for that with the equations, x equals 2, y equals 4. And then like we talked about for our domain and range. Domain using all the input values except for 2, and the range using all the output values except for 4. At this point, let's have you pause the video and try a third function. We're going to look at y equals 1 over the quantity x plus 7 minus 5. Again, think of it comparing it to the parent function, 1 over x. Ask yourselves how many transformations are occurring, do they affect the inputs or the outputs, and use the table to help you. Based on the function, we can see we have two transformations. We're going to be going to the left 7 and down 5. So we're going to do the input changes, the output changes to generate our new points to graph. So once I plot my points and think about the movements that also happened to your asymptotes, this is what our function should look like. Again, by moving it to the left and down, we are going to have an x-intercept and a y-intercept. The y-intercept is always when you have an input of 0, so we could always put 0 into the function and calculate where that is. And then for our x-intercept, we can approximate where it is, but if we want to know exactly where it's at, we could put the function into y1, the 0 in for y2, and find the intersection where they meet. So again, let's check the notation on both x-intercepts and y-intercepts and your asymptotes based on those features. So we said putting the 0 in for y, we've got our y-intercept at about negative 4.857. And then finding the intersection of 0 and the function, we see the x-intercept is at negative 6.80. Our asymptotes, we have x at negative 7, so x equals negative 7, and our y at negative 5. Thinking about not being able to use an input of 7 and an output of 5, our domain and range should be the following. Now you'll continue on the practice, working on your Unit 8, Day 2 worksheet, practicing graphing your rational functions, comparing it to the original rational function 1 over x, thinking about the transformations, creating the graph, and talking about the key features.